So the final session today is maths anxiety and improving resilience. And I think this is quite a good way to end a lot of the conversations that were going on throughout here. We're talking about outreach, and there was a question about, the tutoring and things. And we were just sort of discussing that question because what if the person who you want to do maths is not even receptive to Naira's talk? Like, we're doomed, right? So here, what I want to try and get out of this session, at least for you and for me, is what is maths anxiety? How is it, what are the techniques that are being spoken about, and at the different levels, what is going along? So I'm not going to take much more of your time. Each of the speakers here, they'll introduce themselves, and I'm sure you know most of them as well. And then we'll tell you a little bit about the work that they've done to prompt some further discussions and going forward. So we've got about 20 minutes here before the fireside chat. I'm sure you're going to have many questions going forward. So I'm going to let them say if you can email them about it or discuss in the lobby. But thank you for being here, and I'll pass it over.
Thank you. Meena, Kotecha, and I'm from London School of Economics, Department of Psychological and Behavioral Science. Researchers have been studying mathematics anxiety for more than 65 years, and yet it continues to attract researchers' attention worldwide. It's a global, it's a multidimensional phenomenon, and its sufferers display negative emotions and physiological reactions. These disrupt their cognitive abilities to perform mathematical operations in any context, and so they avoid mathematics. Mathematics anxiety leads to a pattern of global avoidance of mathematics. And as a result, there is STEM skill shortage worldwide. This has an impact on economy. And so on that account, it's a problem of global interest. So what do we know about it? I can't tell you the whole literature, but we've got quite a lot of it. But researchers are in accord on the ultimate consequence of mathematics anxiety, which is underperformance or failure. Past research also tells us that mathematics anxiety develops because of unpleasant learning experiences. This actually has also a long-term impact on its sufferers' academic progression and career choices as well. My work is with university students, and I have found that mathematics anxiety develops because of students' subjective interpretations of their learning experiences rather than actual learning experiences. And recurring negative interpretations of mathematics compel the students to develop or construct unfavorable narratives about mathematics and everything linked to mathematics, the lectures, classes, teachers, exams, coursework, everything. So what we need is, we need to persuade the students and just to encourage them to reconsider their unfavorable narratives. And I think that would be a good start. Also, they need to see the fun side of it, like we've been discussing all day. And to enable them to do that, we need a theory that helps us achieve that. In my work, I have actually used symbolic interactionism to find some solutions to mathematics anxiety. And for those who don't know what it is, symbolic interactionism emerged from seminal works of sociologists and psychologists. And it's very applicable to mathematics anxiety. Thank you.
Hi, I'm Sue Johnston-Wilder. I'm from the University of Warwick, where they don't recognise maths anxiety as a problem, even though 1 in 3 of their staff and students suffers from it, because we did a survey. And I'm founder of the Embryonic International Mathematical Resilience Network. There's a problem in the room that some people think that maths is elite and that you're either born to it or you're not, but that Rishi Sunak thinks that 90% of us will need to use mathematics in our job, and that the children and the teachers are getting mixed messages. So I want to say that some anxiety is normal and that all of us can learn to do more mathematics. Mathematics anxiety is also on a spectrum. Research isn't very clear about when it starts affecting children's and learners' behaviour. So I'm going to suggest that we start in UK with 1 in 3 of the adults and parents and staff members and teachers and teaching assistants that we meet. In Brazil, it's worse. It's more like 1 in 2. As Meena said, it originates in prior adverse experiences, which some of us say are traumatic because they leave an effect in the body. So we're talking about psychological harm. So when I met one lady and she said, "What do you do?" I said, "I work with maths teachers." Her hand goes in front of her face to protect herself subconsciously from further harm. And I say, "What happened to you?" And she says, "I never thought about it like that," because she just thought she was one of the people who couldn't do maths. Examples of adverse prior experiences include being left behind in the lesson. It's not good for any young animal to be left behind, and certainly not children. To be shouted at, humiliated, excluded. "You aren't clever enough to do A-level mathematics." That was a young lady that I know who was taught that. So what did we do? We did AS in 2 years because she needed more time to grow the necessary mathematical neurons. Resilience, I'm pleased to tell you, can be taught. There's plenty of evidence for that. The Maths Resilience Network has gathering evidence to show that a simple toolkit in the hands of teachers, parents and children can change the dialogue in the classrooms and build mathematics resilience and enable children to protect themselves and adults, including a 40-year-old I'm working with, to protect themselves from further harm. That 40-year-old wanted to be a nurse when she was 18, but she couldn't because she had terrible maths anxiety. And working with her, brief intervention, I'm talking about really brief interventions, change her approach to mathematics, and she's now passed her second-year science degree, of her second year. And using this toolkit, children in London are telling each other, "You're not stupid, you're just panicking." That's one of the tools we give them. And panicking is temporary, where the stupid is permanent. Have you asked for another rung? So teachers need to get better at providing more rungs, and not all of us are very skilled at it. Students should be able to expect safe and brave learning spaces and rungs, and they should expect growth-promoting feedback. A little example to root that for you: if a child says 14 in response to what's 4 times 10, we might say, "No, that's wrong." But that wouldn't be formative growth-promoting feedback. We might instead say, "That's an interesting answer. How did you get that?" And try and find out what it is that the child has misunderstood and what it is that they do know already, and build from there. Most of what I want to say is written in our new book, Mathematical Resilience book, which is available, and we're planning another one, an international mathematical resilience book, for 2 years' time. So you have no excuse not to know about the models. But I encourage you all with your students, and encourage your students to encourage the ideas of saying, "I can't do it yet." Of saying, "Failure just means I haven't got enough rungs yet. I can grow more mathematical neurons over time. I need more support. What's available?" What do you do, the audience, when you're stuck with a piece of mathematics? Can we tell more of those stories?
Thank you, Sue. So I'm Lynne McClure, and I hail from Cambridge, where I used to direct part of the Millennium Maths project, which is Enrich, and another project, post-16 project called Underground Maths. And then I moved to direct the Cambridge Maths project. I'm also the chair of the education work stream of the Academy, and I'd be delighted to talk to anybody who wants to know more about what we're doing in the break. I'm not a specialist, actually, in maths anxiety, though I have taught all sorts of ages. And I just thought I'd tell you about 4 of my grandchildren. We do have a bit of a tribe in the McClure house. The oldest one is 16 years old, and she goes to a very competitive school, a grammar school. When she was in primary school, she absolutely loved maths. I should say both of her grandmothers are mathematicians. So, I mean, I'm not sure that's good. Yes, it's good. Yes, it's good. So she's now 16. She's now about to do her GCSEs. But actually, they had covered all of the GCSE syllabus by the time she'd got to the end of year 10. So this year, guess what they're doing? Lots and lots and lots of practice papers. And this is for students who are at the top of the attainment range. So she's got a whole year now of practicing so that she will get her grade 8 or her grade 9 at the end, because that's really important for the school. Perhaps less important for her, but certainly important for the school. Is she anxious? Yes, she's anxious. She doesn't like maths anymore. She did think at one time she'd want to do A-level maths. She certainly won't do A-level maths now. And why is she anxious? Because everything is so disconnected. She doesn't see any of the stories of maths at all. Every unit it's a bit like, what maths have you been doing today? Page 71. She's no idea about the whole stories of maths and the way in which maths is connected. She's also very aware and is anxious that she needs to get a good grade because everybody is expecting that from her. Her 14-year-old sister was excellent at primary school. She's very, very quick at understanding mathematical concepts, and she's absolutely board rigid. Why? Because quite a lot of what she's doing is being taught, again, in disconnected dollops. And very often it's a lot of, this is how you do it. Now, here are some for you to have a go at. She's not anxious, but she's not engaged either. Her 12-year-old sister has just started at secondary school, and she was so excited about the thought of doing really hard maths. And I'm seeing her next week, but the runes are not good. And what's she done? Half a term. Most of what she's done in that half term is repeat what she did in year 6. They have a brother. I know boys are different, but this one is very different. And he's neurodivergent, so he's ADHD. His understanding of the mathematical structure is amazing. He, even from the age of 6 or 7, he could do quite complicated mathematics because he knew the structure of the number system. He could see it, could see number laid out in front of him, and he knew how to work around it. He's very anxious. He's very anxious because being ADHD means that he finds it very difficult to concentrate on anything for any length of time. And so his anxiety sometimes gets in the way. So they're all 4 quite different, and they all 4 come from the same parentage, which is a very educated parentage, with parents who both think mathematics is a very good subject and one which is very important and which they enjoyed. So it's not to do with the home environment, whereas we know that there are lots of students who dislike or don't think that they're any good at maths because their parents say, well, I was never any good at maths, so I don't suppose you'll be any good at maths either. There's no trauma as yet. There's no trauma, but they are, 2 or 3 of them at least are alienated from the idea of doing mathematics. So it's not to do with their family background, it's to do with what's happening in the classroom. And if it starts in primary school, so we have this ridiculous notion that all children are going to learn mathematics at the same speed. If you're learning to play a musical instrument, you don't learn to play a musical instrument at the same speed as everybody else. But why have we got this sense that everybody has to get to the same place at the same age? And why have they got to do it fast? Why have they got to know things so that they can respond like this? Lots of very high-functioning mathematicians do not have lots and lots of things at their fingertips, but they know the way of working it out. So one of the things which has generated the most anxiety in primary children is the times tables test. If you don't know about the times tables test, you ought to go and have a go at it, because it's not a nice feeling. I know my tables, I know them really well, but when you have to do it, each question in a very short period of time, I can feel my anxiety. If Nana can't get all of these right, there's going to be something awfully wrong in the state of Rome. And it's anxiety. The test in itself is anxiety inducing. It's nothing to do with whether I know my tables. It's whether I can respond in a certain period of time. So there are four things, Do my grandchildren value mathematics? I think they all value it for its sort of exchange value. And they know that it could be very useful in the future. They know maths is in everything. And so they probably do want to do well at it, but they don't value it because they enjoy it. Are they prepared to struggle? They're prepared to struggle because they value it. If they didn't value it, they would not be prepared to struggle.
So thanks everyone for the accounts of the work that you're doing and maybe some resources around. I think I want to bring it back to this. So I think maybe as you were listening, you had people in mind that were particularly resonating. I was thinking about my siblings and some of the things you were saying and how that's manifested in them. So my question is, okay, I'm aware of someone who has maths anxiety. What are the resources that are available to me as someone, as an outsider? What can I do to help improve the situation? Now, I know we agreed that we will not answer in question, but I think, do you each want to say something about that from different levels? So let's say at the university, I've got someone who has maths anxiety at university. What would you suggest they do?
I'll actually talk about what I do with my students. So I use social media. And I set up Facebook study groups. And when they just before the new academic year is beginning, 2 weeks before that, I send them out invitations, sending the links to Facebook study groups. And I make it very clear that you don't have to be my friends to join this, because that's important. And Facebook is widely used. I mean, we all know the limitations of it, but it's widely used, and students like using it, and they're familiar with the system. So in order to motivate them, because intrinsic motivation moderates mathematics anxiety. So if what I do is I post articles, news articles, with applications of mathematics or statistics. And the most popular with my students was the dating app. They loved it. And then I asked them to comment on it. And then I said, did you realize that there was a lot of statistics in it? And so I think that's the one way in which one could encourage students to do this. Because as many, you can see that mathematics anxiety starts developing during preschool, as early as that, preschool period, and continues to increase by the time they reach university level. So by the time they're 18, it's very deep-rooted. So I think you just have to try different things and make them see, make them appreciate the interesting, fascinating side of mathematics.
I would agree with Meena. but I think there's a previous step. You can't be engaged and fascinated in something that frightens you. We all need to feel safe in order to learn. So the first thing I would suggest they do is to learn the hand model of the brain, which is Dan Siegel, neuroscientist. There's videos out there that's in the book, but you're carrying around a hand model of your brain. And if you're panicking, the frontal cortex has gone offline. You're not available for maths anymore, you're trying to fight a tiger. C.S. Lewis called it the lion of mathematics. One of my adult staff members at Warwick called it the monster. If you learn the hand model of the brain, then you can say to yourself, I'm not stupid and panicking, I now need to calm down. Before I try and do any mathematics, put my brain back together. And as people in one of my PhD students' thesis said, it's easy when you calm down. And then the second thing I would teach them is how to calm down. And I would draw on the relaxation response, which there's a lovely book of that title written in 2000. It's connected to mindfulness, but we can override our panic response and we can learn to do it, and we need to practice it. So if we find ourselves panicking, we can use 5-7 breathing, we can go for a walk, and we can use strategies that actually work in classes of 60 in South Africa. The third thing we'd introduce them to is the growth zone model, where the youngsters can communicate to their people around them which zone they're in, so that the maths teacher doesn't try and teach them maths if they're in a red zone, but helps them to have time to put the brain back together first. And then to know about the rungs. And I've got a lovely image of which I could send out to if there's a mailing list for this group. If you can't reach the rungs, then you get ones that are closer together. And then you can get up there in the stars with mathematicians.
So I'm not an expert in knowing how to help students with maths anxiety. What I'd like to do is to think about how we could prevent anxiety starting in the first place. And you may have seen it, the government has announced this week a family and teachers project to work with the understanding of mathematics with very small children. And it's not only for the children, it's actually for their parents. So it's bringing their parents in so that their parents become increasingly positive about mathematics, and then that plays out in a manyfold going further on. National Numeracy Strategy, National Numeracy, which is a trustee, which is a charity of which I'm a trustee, also has a project which works with schools. And again, it's working with teachers. So it's not trying to disenfranchise teachers from teaching, but it's helping teachers to work with parents to then help their students. And they have lots and lots of activities and scrapbooks, which are activities for families to do at home. And so far, the results of that are that the students want more and more of it, and the parents want more and more of it. And the activities are very simple activities. They don't require lots of resources, or they're very easily made resources. So that seems to be a good thing. I'd also like to just say a little word about the Maths Futures project, which I had the privilege of being involved with, the project report came out 2 or 3 weeks ago. And one of the things that Maths Futures talks about is having some pathways further up, so in Key Stage 4, so that instead of all students having to follow the same pathway and this ridiculous thing where kids take the exam, then they take it again, then they take it again, 40% of each year's cohort do not pass GCSE mathematics. I think that's a shameful number, and there's something wrong with our assessment system. It's not what's wrong with the children. So Maths Futures talks about having something at Key Stage 3, which is based on some of the really basic, deep conceptual ideas, such as proportional reasoning, so that students, when they start Key Stage 4, have got much less knowledge in the sense of lots of different units, but they've got a much deeper understanding of some of the really basic conceptual ideas. And then that there would be ideas of different sorts of mathematics that students could do. So those who want to go on to do A-level and further maths and maths degrees can still do that much more sophisticated mathematics, but others might use the mathematics that they've already got to recognise the context in which that mathematics can be used. So it's on the website, and if you're interested on the Royal Society website, do have a look. So that didn't answer the question, I'm really sorry.
I'd like to add that 1 in 3 parents has avoidance of maths. Don't ask me, ask your dad, ask your mum. So one of our group, Rosemary Russell, has written a book called How to Help Your Child Do Maths Even If You Don't. And I highly recommend it to anyone who's working with anxious parents.
I wanted to add something that I found important from the viewpoint of what students report. And I think we already talked about collaboration in the previous session. And I think students have this misconception that mathematics is done, mathematics or statistics or anything quantitative, it's done in isolation. And I encourage them to collaborate. And again, I would like to say that my Facebook study groups actually help them collaborate with one another during the after term time, outside term times, or revision period when the teaching has stopped. And then they have access to me, but they also have access to one another. So I think collaboration is also important. Thanks.
So we've heard quite a few resources there. So we've got Sue's book, there's Enrich as well, and the Maths Futures. Meena is also with the IMA doing a conference next year on maths anxiety, so there's a small plug for that. We need to move on to the fireside chat soon, so I'm going to, apologies there's no questions, but I'm sure they're around, but I want to finish this with, if there's one thing you want everyone in this room to take away from this session, what would that be?
Thank you. I would say that anxiety is normal. And also that it has got positives. It actually improves performance up to a certain point. So some anxiety or moderate anxiety is okay. So I think it's important to convey that to students. But then they don't want to go into panic and they don't want to feel threatened. And I think that is a danger point. But before that happens, if they understand that anxiety is normal, then they will not get into that threatened stage. Thank you.
I want to convey that the panic zone is a beach, not a cliff. If you find yourself panicking, you can get out of it. And so it's okay to get your feet wet, to start realising you're panicking, as long as you know how to get out of that space.
So I would say that Frances Sue wrote a book called Maths for Human Flourishing, and I would like to think that we could work towards a maths education which allowed all students to flourish, no matter how they attain.
So thanks everyone for sticking around. I guess we're moving on to the next session now. So thanks again. And I would like to take the opportunity to thank all the speakers throughout all the sessions. So thank you very much.